Hey everyone, this video is a review of mutually exclusive versus overlapping, just a couple quick examples to kind of put it all together. So remember here we're talking about compound events or compound probability, which is two or more events being combined. And then to determine whether they're mutually exclusive or overlapping, we want to ask the question, can someone or something fit into both categories? Now, if I asked you from a group of people, what's the probability of choosing somebody with that's a brunette or a blonde? Those would be mutually exclusive because you can't be both. However, if I said, what's the probability of choosing somebody that is a female or has brown hair, it's possible to be a female with brown hair. That's an example of overlapping. So remember, mutually exclusive events, key word here is the word exclusive. It's two or more events that cannot occur at the same time. They have no common outcomes. And then to find them, we just add our probabilities together. So remember, as a Venn diagram, I'm going to let the circle on the left be A, the circle on the right be B. To find the probability of either of them happening, we do the probability of A plus the probability of B. It doesn't get much more difficult than that because if I highlight circle A in yellow and circle B in blue, what you should notice is that neither of the colors change. That means there's no overlapping area. You just add them together. Now, overlapping events, two or more events that have at least one common outcome. They can have more than one, but they have to have at least one. Just like mutually exclusive, we're going to add the probabilities together, but we're going to subtract the overlapping area. I know this should all be a review, but these Venn diagrams really help break it down visually. So circle A and circle B. I'm going to do the probability of A plus the probability of B, just like we did the last time. Here's circle A in yellow and circle B in blue. Now, what we should be noticing is we have a new color here, the color green. This is because I've highlighted this middle section in both yellow and blue, which means I've double counted it. So I want to make sure I subtract the probability of A intersect B, the probability of A and B where they overlap. And that would be in green. So a couple quick examples. Once again, we see this chart that you're going to see a lot with probability. So we just want to fill in our sums. Remember, when you add up all these sums together, you have a total of 36 outcomes. That's going to be our denominator every time. So I want to find the probability of rolling a sum of 3 or a sum of 8. So just like we did with the Venn diagrams, I'm going to highlight. So sum of 3, that's 2 out of 36. Remember, we're not simplifying our fractions until the very end after we've added them together. Or a sum of 8, that's 5 out of 36. Notice that there's no green color here. That tells us that these are mutually exclusive events. We're going to get a final answer of 7 out of 36. Now for the next one, the probability of rolling an even sum, or a sum that's a multiple of 5. So an even sum, we're going to highlight all the even numbers. Which is 18 out of 36. plus a sum that's a multiple of 5. So multiple of 5, those are, for example, 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. So it's going to be 5, 10, 15, 20, so on and so forth. So I'm going to highlight the 5 and the 10s, which is going to be 7 out of 36. Now, what you should notice is 3 numbers have changed to green, the 3 10s, because 10 is even and a multiple of 5. So I have to make sure I subtract 3 out of 36, which is going to give me a final answer of 22 over 36, or 11 over 18. I can't stress enough, highlighters in this case, really, really easy to use and to help you tell. All right, so my standard deck of cards, we're going to find the probability of drawing a face card or an ace. So face card, that's going to be those 12 cards out of, remember, a total of 52. Or the probability of an ace, that's these 4 cards. If we look at our deck of cards, there is nothing highlighted in green. These would be mutually exclusive. We just add them together and then reduce. And our last example, probability of drawing a spade. So that's going to be these 13 cards out of 52, or a number card. That's going to be these 36 cards. And then what you notice is the 2 through 10 of spades has changed to green. So I want to make sure I subtract those 9 cards, which is going to give us 40 over 52, or 10 over 13.